You're listening to China Manufacturing Decoded from the Sofeast Group. Hello, welcome back. It's episode 233 of China Manufacturing Decoded, the podcast from Sofeast. Adrian here, and Renaud joins me this time. Hi, Renaud.
Yeah, how you doing? Hi, everybody.
Good, thank you. Yes, thank you. And yourself?
Not bad, not bad. Things are going well.
Mm-hmm. Last week, you were talking about an interesting book that you'd read. That was, well, it's kind of about supply chain logistics and the way you were framing it, the automation's impact on supply chains. It's called Arriving Today. I'm not going to say the full the full title because it's quite long, but yeah, good book that.
Right. Interesting. Yeah. It's not a new book, but I heard about that. I had a look and I go, okay, let's see what this reporter found by following the supply chain, basically, of a standard consumer electronic product from a factory in Vietnam all the way to a home in the USA through the logistical hubs and, the shipping vessel and the long haul trucking and all these things. It's kind of interesting.
Yeah.
It's from maybe 3 years back.
Yeah, 01, I think.
It's the same system as today.
So 2021. Yeah. No, interesting. Because we don't really think about it when you just buy on Amazon, for example. Click pay. It's arriving in, tomorrow if you've got Prime or whatever, maybe sooner in the big cities. And then that's it. You don't think about it. But actually, yeah, there's a lot involved. So, yeah, I enjoyed that. If you haven't heard that one yet, that's last week's episode. So do have a listen. And actually, we're still talking about typical consumer electronic products, right, this week. And I think it's not uncommon for customers to ask us, how much is it going to cost to take my product concept to the market? So actually get it into mass production and get it on shelves. There's no way to give a dollar value for that. It's going to vary depending on the product, depending on just many, many, many factors. But I'm going to set you the task of trying to kind of explain that in this particular podcast, right? I suppose the way you're going to go through some sort of milestones, some of the tasks that must be achieved on that journey, and some example costs while, relating it to a typical consumer electronic product, which is typically what we would be helping people with here at Sofeast. So with this in mind, we probably covered this similarly more than a couple of years ago. And I'll link back to the related content that we've already created on this topic. But we're going to be going fresh right now. So yeah, what sort of product would you say is a good example?
It could go from a power bank with a couple of extra features to a coffee machine to e-scooters to. I mean, it's very wide, right?
Yeah.
From food processing products to, I don't know, boxes that will open remotely when the delivery guy is arriving and close. It's very, very wide.
Yeah.
You can just look at some popular categories in Kickstarter, from keyboard for gamers. It seems like there's a never-ending pool of new designs there.
Yeah,
right?
Yeah, definitely.
It's a very wide range of products. We work mostly on electronic products, but let's say electromechanical products, because, well, a lot of the same things come in play when it's purely mechanical.
Sure.
And you remove a good bunch of the complexity when there's no electronics, of course, right? So it's actually a very, very hard question to answer, what is it going to cost? Well, it's more like, what are the cost drivers? That's a much better question, because otherwise there's no way to answer.
Yeah.
So,
yeah. But and part of our job is to set expectations, right? So if a customer comes to us and asks that question, we're going to try and help to guide them to understand the process that they need to go through, right?
Yeah, And there's so many questions. Again, it's about the cost drivers, right? And first one is, okay, do you want to develop this from scratch? Do you have the budget? So again, yeah, we need to have a rough estimate, and usually from a concept and initial design, at least initial industrial design, we can say, well, it's going to be at least whatever, $50,000 in to get to a final prototype, and then to industrialize it, get it ready for mass production. Maybe it's going to be, I don't know, $80,000, and then including compliance testing and reliability testing and so on. And then to get it going, well, you're also going to have to pay to get production going, because you have to pay usually before you get the products that you can sell and then collect the money on, usually. Okay. So you add these three things up, and you have a rough idea about how much cash you're going to have to shell out before you get anything back. All right. Now, if there's no way you can do that, you don't have the funding, you don't have the connection to investors, you don't have any kind of market traction that can, even allow you to go do a Kickstarter or really get some interest from investors. Okay, well, if that's not possible, that's your first business, you're a startup. Maybe you should start actually by getting good at marketing a product, at managing inventory, at working with an overseas supplier. Then you pick an existing product and you give inspiration to the supplier to do one or two things a little bit custom for you, hopefully, or maybe you don't even need that. And you do your branding and you do your online sales shop, or maybe it's on Amazon. Okay, you develop one or two sales channels and the marketing to push the products, and you're going to learn a ton in that space just by doing that for maybe 1 year. And maybe you will be much more ready for going into a big, ambitious, expensive new product development project, right? So one step at a time, right? You're going up the staircase, and don't try to jump all the way up to the first floor, right? Try to do something maybe with, just private labeling some existing products. Then you go and add one or two features, semi-customize it a little bit. Now, it's not your product yet. Your business is not worth very much, for sure, but at least you are learning what's going on in the market. What are the pain points, what people are not very happy about, what people would be so happy to get their hands on. You get some insights that otherwise you would not have. So it really de-risks the launch of a new concept, a new product, right? So that's really the first big question. Okay. So, and that's why sometimes we challenge people. We say, well, wait a minute, like, you don't really have a budget. You don't really have a target market with traction. These are the two key elements. And also maybe you don't have any experience running a business. Well, we can see a lot of pain in your future, in your immediate future. So maybe you should go one step at a time. Okay, so that's the first thing. Now, if you really want to go for the development of a new product from scratch, again, there's three big things. There's, I should say, actually four big things. Okay, if we think in big phases, the first one is to actually get to the point where you have a product concept that is relatively, interesting and mature, and you have done the job to actually compare maybe a few alternatives about the design architecture, and you have an idea. Okay, like, it's not just an idea, basically, right? It's, you have some product requirements you have in mind. So it should be maximum this size and this weight, and it should go out, and it should be waterproof, and all these kind of things. And whatever, the Bluetooth should still work. in open air, 100 meters away in some cases, etc., etc. Okay, then what that really orients people in the right direction, right? And you have an industrial design, at least the renderings, and you have your high level design architecture. Okay. So that's really, to me, that is a really big milestone because that clarifies so many questions.
Mm.
And at that point, estimating the cost is already much easier. When you just have a concept in your head, like there's no way to really estimate the cost. Okay. Like whatever people tell you, there's no way, except if it's really close to an existing product.
Mm-hmm.
But here we're talking really about new products, innovative new products, new form and function, new application, maybe new application of the technology, etc. Okay. Because at that point, you already know, okay, let's pick, let's say it's this kind of battery and this kind of, I don't know, display. And let's imagine the enclosure is going to be in plastic and yada, 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 and we're going to have a board and we're going to have, this sensor and this sensor and this chipset. Okay, already a little bit of sourcing work, and we have an initial bill of material, very high level. But you already have an idea if the bill of material is going to be $10 or $50 or $100, right?
Mm.
So that really helps have an idea about the unit cost. And I would say that's the first thing you want to estimate, even before you estimate all the non-recurring engineering work to get to the final prototype and to get to production readiness and so on. First, you want to know if your landed cost in your main market is going to be closer to, again, 10, 50 or $100. Okay. Because that tells you, okay, you're going to have to sell it for that price. Can you do that? Right.
Mm.
And then you have to do your market research, and with your renderings and maybe some crude prototypes and whatever, maybe you take a competitive product and you mess with it and you have something extra, maybe just in cardboard, you say people, well, Imagine it does that and that's the cost and that's how it works. What do you think? Do you think it should cost this much or this much or this much? You try to nail your target market. Okay, anyway, the whole thing about market research and customer development and whatever they call it, that's a whole art in itself.
Mm.
And if you are funding your startup, you should spend a lot of time on that. If you are in an established company, you gotta have something like a product manager, or maybe it's product marketing, or however you're organized. You need someone to really go deep in that. Okay, really go out, meet the right kind of people, or maybe do some interviews with them on Zoom and so on. But you get to really get some qualitative feedback. Okay, because that will give you a lot of ideas also about how to make the concept better.
Yeah.
Okay, so I would say most important is to estimate the full landed cost of the product. And when you have an idea about the BOM cost, already that gives you an idea. If you have all the critical components, the total cost roughly, then you add, I don't know, maybe you add 20%. Well, if you do some proper sorting work, you can probably get the price down, but you're going to also have a bunch of other elements that will go into the BOM, right? And then on that, you add another 10, 20% to get the full cost of the product, with assembly, testing, etc. And then you have the shipment. Well, that kind of depends on whether, it's big and heavy, whether you're going to want to do sea versus air. So there's, it's a little bit harder to estimate. And then you have your landed cost. Maybe you have some duties, maybe you have some high tariffs, who knows, right? So that's the first thing you want to try to nail. Okay.
Mm.
So I mentioned there's 4 big phases, right? So the first one, as I mentioned, you have some documented product requirements, you have a industrial design, at least renderings, you have an initial bill of material, and you use that to get some feedback from the market. Okay. Then the next one is to go through prototyping, work like prototypes and look like prototypes and so on, and then get it all together into some engineering prototypes that are pretty close to what you want, that are fully functional, the right form, the right function, everything. And really, that is usually expensive for complex products, right? So you might have some mechanical design to do, and that could be $10,000 if it's really relatively simple, no big complexity, or it could be $50,000 if there are some internal moving elements, some gears and so on, and there's it has to be waterproof maybe, and so on. And maybe it could be much worse, a much higher number. Okay, you have the electronic design, the high level electronic design and the design of the printed circuit board, and really picking the right components and running some prototypes and again and testing them. Okay, that doesn't come too cheap. It's often a bit higher than mechanical design. And then if you have some embedded software, some firmware, wow, that can be a killer. Okay, so we're saying maybe, okay, if it's not very complicated, maybe $5,000 for mechanical design, maybe $10,000, $15,000, $20,000 maybe for electronic design. Again, depends on the complexity. And then for firmware, another $10,000+ easily, if it's complicated. Okay, then you have maybe the mobile application. Okay. And again, if it's relatively simple, you pay a UX and UI designer, maybe a few $1,000s, and then you pay for the actual development. Totally depends on the complexity. Again, maybe $5,000, maybe $10,000, depends how in depth you want to go. So all of that, and of course you have the materials that you buy for prototyping and doing the prototyping, etc. Okay, and that depends on a number of iterations. So one big thing that is missing, usually if we just talk about the cost, is the timelines and a number of iterations. So some people, some companies, they want to develop, a new product, and they put some internal resources. Okay, maybe it's an established company. They have some engineering resources internally. They will use that. Maybe they hire someone specifically. Maybe it's a startup, and what we see often is that one or two of the founders are technical, and they will go deep into their area, maybe the mechanical side, maybe the software side, maybe the electronic side, right? And that also has a cost. They have a lot of work to do. And the thing is, in most cases, a big mistake is to come up with a product that is too complicated for version 1. And often it's not just one product that you're trying to develop, but it's kind of 2 or 3 products that are supposed to come together. That's usually the way I frame it when I see this a lot of complexity, different modules of the product. And that might mean not just 1 or 2 prototyping iterations. It might mean, 8, 10, 12, 15 iterations of prototypes. Let's not even talk about the big boys like Apple. Nobody knows how many dozens of iterations they make just to get to prototypes, again, that are fully functional and look good enough, close enough to the color, material, finishes that are necessary, that are required. Okay. So that is a big milestone when you can say, okay, we can freeze the design. Now, also one thing people are missing here is accelerated reliability testing, because the problem with electromechanical products is that if they fail too early, usually users will complain, will give, poor ratings, will send it for return. Very often there is some kind of warranty. So that can add up to big bucks quickly. Okay. And if you don't actually push the prototypes, you put them under stress, and in some cases you push them until failure. Okay. You try to replicate the intended usage in the intended environment of the expected stresses, and then you see what fails first. And that really also informs you when you plan for the next design iteration. Okay, what should we do here? This part is failing. Why is it failing? How is it failing? Okay, do we need to add redundancy? Do we need to change the material? Do we need whatever, right? That's really important, but that doesn't come free, right? That doesn't come free. Also testing in the lab. And also you might need to do some pre-testing for compliance and safety. So we've been working on a few products that will be sold in the US and in the EU and plug into the wall and so on. So electrical safety is really a scary topic. And we always tell them, well, you get to do some pre-testing. Get a few prototypes, send them to a lab. They will take the appropriate standard, the whatever, IEC 60, what is it, 335-1- something, whatever is applicable. Or maybe if it's a audio video or IT product, IEC 62368-1. Okay, so the lab will just follow the technical standard, and it might be a UL standard, by the way, 1065 and so on. And the lab will simply follow the technical standard that tells them exactly this is how you make this test, and this is what's acceptable, not acceptable, etc., etc. And well, sometimes they come back and they say, well, we did this kind of test and it failed that way. Okay, so now we can think about that and adjust the design. And why am I saying that all these validations of the product design are so important? Well, for a very simple reason. Once you have frozen your design and you have done you fabricated some tooling, you really don't want to change your product design. Because maybe you have to redo the tooling, which takes costs, sometimes a lot of costs, sometimes $50,000, $100,000 and up. It depends on the number of course, custom-made parts and what materials and so on. I mean, custom design parts. But also, if you can still do a tooling revision, that also takes time and money, right? So you really want to test and validate and take care of these big questions, big annoying uncertainties, and take them away, right? So that takes cost, when you do pre-testing in a local lab, and maybe you take the standard and you say, well, only test against this, and this, because the rest we don't really see a very high risk. It might be $2,000. It might be, again, very dependent on the type of product. But all of this adds up. So that's the point. So you get to the point where it's frozen and it's ready to open tooling, and to go into some other validations. So tooling, if it's a product the size of a mug, like a mug just to drink your tea from, right? And you have two simple plastic parts, that might be less than $10,000. But if you have something, well, you can just Google, I think it was the Juicero, Guicero. They did a teardown of that Juicero product, and it was just wild, with so many custom parts. That was a $700. electrical home appliance, let's say kitchen appliance, right? It was just wild. The cost of the tooling for that is in the hundreds of thousands of dollars. Okay. Even if they went with soft steel. So it very much depends. Very much depends on how many custom design parts, what's their geometry, what is the material, because if you want something to be made in silicon, especially silicon compression molding, the tooling will be less expensive than plastic, or die casting, right? Okay, so tooling is usually one big outlay of cash. And then once you have tooling and you make samples based off tooling, so of course, make samples, so it means you need to buy more of the other components, to make some more prototypes, and you need to pay people to actually put these prototypes together. Well, now is the time to do compliance and safety testing or certifications, right? And again, very, very dependent. You have RF testing. In the US, it depends if it's non-intentional versus intentional. The cost might go from 2,000 to 10,000 and up in US dollar. In the EU, if you want CE marking, also you need to do probably radioelectric directive, and the technical standards that come under that. And that includes electrical safety. Anyway, I'm not going to go through all of that. You also have some chemical testing and so on. So that's, let's say, between 3,000 to 5,000 on the low end and maybe 20,000. But again, very dependent on the kind of product. Okay. You got to keep some margin for that. And then you want to also do some live tests, kind of reliability testing, just to validate that everything is all right. Okay. So a few $1,000s here also. And then you obviously have some people need to prepare the production process and the quality standard, and all of that needs to be documented. And you need to go into a small pre-production pilot run, and there needs to be some kind of setup for all of that, right? And if you work with a contract manufacturer, they're going to charge you for the time they spend on this. Okay, so a few more $1,000 right here. And then you get to the big milestone where, okay, it's basically ready for production. And now production time means ordering a batch of, batches of components, right? And if you picked a specific component that has a minimum order quantity of 20,000, you're going to have to get the cash out to get 20,000 of this. Now, maybe you only want 500 pieces first, then 1,000 and so on. You want to start relatively small, at least for China, that's considered small. And that's fine, as long as you pick the right manufacturer, of course. That's fine. But the manufacturer is not going to buy 20,000 pieces of something that they only need for your project, and finance it all by themselves. Usually you will be required to send money for that. Okay. So you have to pay usually 30% down for the quantity of product. So if it's 1,000 products, pieces times whatever, let's say $20, then you multiply and you know how much money you get to put out. And then once that's done, you still need to arrange for logistics. So a few more $1,000, or if you're really in a hurry and you want to ship a lot of products by air freight, might be more than $10,000. And when it arrives, what's the import duty? What's the tariffs if you are sending it, for example, to the USA and it's on the list of these Trump tariffs?
Yeah.
Maybe Biden tariffs, right? And you also need to arrange the logistics all the way to your warehouse. Maybe it's going to be in your garage. Maybe you are using some, one of these fulfillment service providers here and there. that will charge you for the warehousing space and the manpower and so on. And then you need to fulfill, if it's to stores, maybe you just send it to, I don't know, 10 or 20 or 50 stores. But if you have sold it in e-commerce, well, that's a different story. You need to fulfill to people's homes, basically.
Yeah.
Or offices, right? So that's a lot of work, and maybe you charge that to them on top, maybe you don't. So a lot of things come into play. Again, what I'm just trying to say here is, what are the cost drivers, right? I don't know. Maybe should we talk about some big mistakes that people make, or as I'm thinking about that, a big mistake. Yeah, a big mistake is to, when you are in product development, maybe to go in the wrong direction with the wrong design architecture. And sometimes people have to work 6 months in a certain direction, and they just have to, they hit a wall, they try, and they say, okay, we got to go back to a different design architecture. Maybe we picked the wrong chipset. This chipset is actually not for this application. How come we did not even check that, right? So that's really a big one. If you've put a design team for 6 months to work in a certain direction, do iterations, and then keep banging the wall, and they keep trying, and they keep making prototypes, and they keep testing, and it keeps being thrown to the rubbish, that's already a lot of money down the drain, right? Now, then another one during product development is to design something without taking into account the realities of manufacturing and assembly. So there's a bunch of these big high visibility Kickstarter projects where they say, oh, here's our amazing product, and it has all these features, and it's so cool, and then they just never deliver, or they have to go through a deep redesign, and they have to spend an extra 6 months or 1 year before they get into production, or even longer sometimes, right?
And maybe don't then, because they've had to redesign, don't actually reach the promises they originally made. So the backers are still peed.
Oh, some of them completely fail. They never deliver anything.
Yeah.
Okay, so that's really terrible. So design for manufacturing and assembly, you got to get the feedback. You got to get reviews of the design by people, who know what can be made by their component suppliers, and what they can assemble, what they can test, etc. And if they tell you, this is not going to be good, you're not going to do nice anodizing on this die-cast part in that kind of alloy, like, or powder coating this in silver color. Nah, like, we're going to have a lot of quality issues, right? Or maybe sometimes it just can't be done. Like, you can 3D print this enclosure, but not injection get it, right? You got to go back to the drawing board and make some deep changes. Okay, so very important to integrate that. But maybe the one biggest mistake is people design something and they're very secretive about it, and they say, oh, I'm in stealth mode, I cannot tell you what I'm doing, whatever. And they're very paranoid about, all these companies in Shenzhen, they will, if they see it, like, they will go after it and so on. And then they spend sometimes more than a year, and maybe they spend $500,000 or $1 million, to develop something very complicated, very sophisticated, and nobody wants it, right? So that is the biggest waste of all. That is the biggest waste of all, right? And there's so many products like this, even, including from pretty big companies. They just bomb completely because they did not do market research, and they did not get the feedback. about what people are willing to pay and what kind of people are going to use this and how to market it to these people. What are the claims that they are sensitive to and all these kind of things. Okay, so these are some big no-nos. Obviously, working with the wrong contract manufacturer, that's or OEM supplier or ODM supplier, whatever. That's a classic, but we covered that already in previous episodes.
Oh yeah.
Get to pick people that have the right, the capabilities to do what you want to do, and that are, the right kind of business, a good fit for you, and so on and so forth. Okay, so these are some of the pretty big, painful mistakes.
Absolutely. If only there was a series of podcast episodes where people in the know talked all about vetting the right supplier. I wonder where people could listen to that.
Right. I'm sure you're going to send a link to that, right?
In the show notes, as ever. Yes, I'm sure everybody listening, they've got to have heard me say I'll put all the links to related content in the show notes like hundreds of times now. So yeah, it's definitely worth checking out. It's a good point. I think going through kind of like the touchstones of the process to get from concept to product and get it actually into consumers' hands, via, I don't know, distribution channels or whatever, that it's quite a holistic view of what needs to be done. And yes, you've given some rough costs along the way as well, which hopefully it starts to sort of crystallize in your mind, okay, this is roughly maybe what we're talking about cost-wise. But I think the mistakes are important as well, because what you don't want to do is end up inflating your costs or derailing the project completely by making mistakes. So I think those two things are useful to mention hand in hand. And yeah, I think, for any customer that's asking us the question, I would absolutely now refer them to this episode and they can go listen to that, as well as, doing their research and whatever. So yeah, a useful topic. And regarding the products that failed, yes, we've written about it and spoken about them. So yeah, links in the show notes.
Thanks. All right.
Great. So that wraps up this one. And as we always are, we will be back next week. Thanks again for listening to this podcast brought to you by the Sofeast Group. We're on a mission to provide you with everything you need to manufacture effectively in Asia, including inspections, auditing, new product development support, contract manufacturing, 3PL warehousing and fulfillment, and much, much more across Asia's key manufacturing areas. Visit us at sofeast.com, that's SOFEAST.com, to learn more and get help. If you've enjoyed the podcast today, please do rate, review and share, because it will really help others discover us too.